Okay, welcome to my garage. We are looking at 9.4 perform rotations, and we're going to do this here in my wonderful garage. I have my high-tech video studio ready to go, and hopefully this is helpful for you. 9.4. You know that we've been moving through chapter 9 on transformations. 9.1 we did translation. We just slide this thing. You will remember that when you see the little tick mark there, that's A prime, and you think of that tick mark as the letter I for image. And so A prime, B prime, C prime here is the image, and so therefore A, B, C is your pre-image. So you start with the pre-image and then you slide over to the image. Go from A, in this case here, go from C to C prime. We also looked at reflections, and you'll remember that we have a line of reflection, and it has to be a perpendicular line of sight with the line of reflection. So B is 2 steps to go to the line of reflection, and we want to go 2 steps beyond the line of reflection. So we go from B to B prime. And now we are looking at rotations. And this is 9.4. And so this little small diagram that you have there in the summary, I have blown that up, and that's on the back side of your 9.4 notes. So we will get to that in just a minute. So let's walk through the notes, and then we'll go to the back side in just a minute. So recall that a rotation is a transformation in which a figure is turned about a fixed point called a center of rotation. So in other words, if you have a figure, see here is your pre-image, it does not have the prime marks, here is your image. If you have a figure and you are told to rotate this figure, the next question you should have is, rotate it about what point? In other words, what is my center of rotation? Here's my handy dandy tracing paper, and I'm here at my home. I didn't have my tracing paper, so I was able to find, thankfully, my wife has some genuine parchment paper, oven safe and non-stick, and so this is sufficient to be my tracing paper. Parchment paper also works very well for tracing paper. So here's my pre-image, and like I was saying, you have to ask the question, what do you want to rotate this pre-image about? Do you want to rotate it about this point here? If so, then it's going to go around like that. Or rotate it up here, it's going to go around like that. But in this case, they want our center of rotation to be down here. So here's my pre-image. Here's my center of rotation. I hold down on that center of rotation, and you can see how that rotates the pre-image over onto the image. You're going from R up here over to R prime, and going from Q over to Q prime. Okay? Then it says that the rays drawn from the center of rotation to a point and its image form the angle of rotation. So what that means is this ray going from the center of rotation to the pre-image, and then this ray going from the center of rotation to the image, the angle between those two rays, that is your angle of rotation. So you might be tempted to think, okay, my angle of rotation is some angle between these two. No, that's not the case at all. You know what though? I bet if you were to extend these, I bet that would be 40 degrees. But the angle of rotation that we're measuring is going from the center of rotation to the pre-image. That's one ray. The other ray is the center to the image. That is your angle of rotation. Okay. So let's talk about how to do this. So now flip over your notes on the back side of your 9.4. I've just made a second copy here. And notice here that I have some diagrams for you. This is what comes out of the book. That might be helpful to you. But this is what I would like to focus on. This is what I've created, and I think it's more helpful to you. But they're saying the same thing, just so you know. Two different ways of saying the same thing. So let's first of all talk about, here's your point here, and make sure that you understand that a positive rotation is going counterclockwise. So so notice here, and the way you remember that is by looking at the quadrants. You know this is the first quadrant, and the second quadrant is counterclockwise to that. So let me show you what we're doing. Here is a point. Let's consider this to be your pre-image, and I want to rotate it around the origin. For all of our rotations, they will always be about the origin. It's still important for them to indicate that, and for us to talk about that. We are rotating about the origin, but for all of our problems that we're doing, at least in this section, it will be about the origin. Later, the FSA may include some rotations that are not about the origin, and we'll talk about these. But let's start with the basics. And notice here, if I rotate it 90 degrees, now when I say 90 degrees, I mean a positive 90 degrees. So what direction is that? Is that clockwise? Is that going the same direction as the clock? No, it's not. It's going the same direction as the quadrants. Here's quadrant 1, there's quadrant 2, so it's counterclockwise. So a positive rotation is counterclockwise. So this point here would, 90 degree rotation, would rotate it over to here on your coordinate grid. And the way that I like for you to remember that is by breaking this up into a horizontal leg. So here's your point. Break this point up into the horizontal leg, that's the blue, and also a vertical leg. So how long, if the coordinate points are 2, 1, how long is this horizontal leg? Well, it is 2. That's 2 blocks long. And then how long is this vertical leg? It is 1 block long. And then when I rotate this, I can, using tracing paper, of course, is easy. You just hold down at your center of rotation, which in this case is the origin, and then I rotate it around. And notice that it comes around here. And yes, it is true that it doesn't come exactly here, because I'm the one that created this graphic, and I did not make these legs here the same length. But let's just imagine and pretend that it does line up here. So this length here that used to be over here is the same length. Right? I've taken this and I've moved it around, so it's the same length. So it's going 2 up, and then this green leg, what used to be the vertical leg, is the same length of 1 block, and so it goes 1 block to the left. So now what are the coordinates of this point? Well, remember, go back to the origin and do your x coordinate first. So my x is going to be back, I'm going a -1, and then my y is going to be a +2. So a 90 degree positive rotation goes from, takes a 2, 1 over to a -1. Remember, you're -1 on the x coordinate, and then +2 on the y coordinate. So I think that's the easiest way to remember it, is by breaking it up into these little horizontal component and then rotate it around. Just look at the horizontal as you rotate this around, and then when you try to decide, okay, what direction do I go for the green leg, this vertical leg, think about what you did before. You drove your little car down from the origin, drove your little car down the blue horizontal road, and then you took a left-hand turn down the green road. So when this rotates around, when it rotates around going like this, notice that the road does not change. It still stays the same. You still go down the blue road 2 blocks, and then you turn left on the green road and go 1 block, just as we had done here before. 2 blocks, turn left, go 1 block down the green. See what I'm saying? Hopefully that's starting to begin to solidify into your mind now. So again, we go down here and then turn left. Now you can use formulas. If you want to use formulas, then a 90 degree, a positive 90 degree rotation, which is counterclockwise 90 degrees, what you'll do is x comma y will turn into negative y comma x. So what I mean by that is what used to be the x coordinate, what used to be the y coordinate now turns into the x coordinate, and you take the opposite of that. So if it was positive 1, it's going to turn into a negative 1. And what used to be the x coordinate, used to be 2, or the x coordinate is 2, but take that number and that turns into your y coordinate. So if you want to remember these rules, that x comma y turns into negative y comma x, you're welcome to do that. If that makes sense to you, then go to it. To me, what's easier to remember is the graphics, and breaking it into horizontal leg and vertical leg, and then rotate that horizontal leg the direction you want to go. These are the rules that are the same here. So notice that I'm saying x comma y goes to negative x comma x. I'm sorry, negative y comma x. That's the same thing that they're saying up here. A comma b goes to negative b comma a. They're just, instead of using x comma y, they're using b, a and b. In fact, you could just do this if you wanted to. Put x comma y on top of that, and then do an arrow, and then so this is going to turn into negative y comma x. Just so you know how to connect those two different notations, two different ways of saying the same thing. Now if you wanted to do a positive 180 degree rotation, you start with your same horizontal leg and vertical leg, hold down at the origin, and notice what I'm doing. I'm going all the way 180 degrees all the way around here, but it's still the same arrangement. I still go down the blue road 2 units, and I turn left onto the green road. Just make sure that you get your orientation and think of yourself driving down the road. You turn left. Same thing if I do a 270 degree rotation. Now yes, it is true from our orientation right now that we are going to the right on the green road, but twist your paper around and see you're driving down the blue road and you turn left onto the green road. So be careful with that. When you rotate around, make sure that you know and get it correct whether what used to be the vertical leg goes to the right or to the left. So think of yourself driving down the road and you turn left onto the green vertical road. Okay, of course we're going to practice this in class, and here are your other rules if you wanted to do it for 180 degrees, and also for now this could be a counterclockwise 270 degrees if you wanted to. That's the same thing as a clockwise 90 degrees, which is the same thing, which is another way of saying a negative 90 degrees. Because remember, positive rotation goes counterclockwise. Quadrant 1, quadrant 2, 3 and 4, it's counterclockwise, positive. A negative rotation is going clockwise. So a negative rotation would be going clockwise around down here. But notice that's the same thing as if I would have done a counterclockwise 270 degree rotation. So whether I go 270 degrees counterclockwise or I go 90 degrees clockwise, it ends up in the same place. Now let's take those principles and apply it specifically to this here problem. And we want to graph triangle JKL with vertices J, K, and L, as you see noted there. And we want to rotate this triangle 90 degrees about the origin. So first of all, let's plot this dude. So remember how to plot. Be careful with that. Do your X and your Y coordinates carefully. And once you have plotted the points, I've done it in pen here just to make, or actually a marker, just to make it look clear for you. But I would recommend you do yours in pencil because it's very easy to make mistakes and you want to be able to erase it. But once you plotted your 3 points, then label those 3 points. Please label those 3 points. And label them in such a way that they don't get, it's not on top of each other and kind of messy. So I had to put them out on the corners here. So now you want to rotate this thing 90 degrees. So what does that mean? Am I going clockwise or counterclockwise? Well, notice it's a positive 90 degrees. Here's my first quadrant. My second quadrant is to the left. So counterclockwise is a positive rotation. Okay, so here's my triangle, and I want to rotate this counterclockwise. So do I just grab my little thing and rotate it around counterclockwise? No way, Jose. Remember, it says about the origin. So when it says about the origin, what it's talking about, it's telling you what the center of rotation is. So the center of rotation is the origin. Ah, okay. So here's my pre-image, and I want to hold down on my tracing paper. I know you don't have tracing paper at home unless you want to use your mom's parchment paper, but to hold down on the origin, and you would then rotate counterclockwise. So we're going from this, and you should be able to visualize this at least in your mind, that I want to rotate it counterclockwise there. Okay, so but how do I do that? Without graphing paper or this tracing paper, and just using your coordinate grid, what you do is take point J. Remember, only do one point at a time, so ignore all the other points. Just take point J here and break it down into a horizontal and a vertical component. So here's my horizontal component of 1, 2, 3, and in fact I do not have a vertical component. That makes it a little bit easier. And I want to take this horizontal component, I can just use my pen if I wanted to, or pencil, and think of it, okay, now I'm rotating it about the origin. So it's 3 blocks going to the right, rotate this guy around, and I want to go 3 blocks up now. Here with my tracing paper it's a little bit easier to see. I'm going 3 blocks to the right, and now rotate that counterclockwise, so I want to go 3 blocks up. But again, you do not need tracing paper. Just use your pencil, just kind of visualize it. You're going 90 degrees. See that 90 degree rotation counterclockwise? So I'm going 3 blocks up. Now the question is, if I start with J, what is this point here called now? It's called J prime. So here's your image, J. It's going to the J prime of your pre-image. And what are the coordinates of that point? Well, remember, start back at the origin and do your x coordinate first. So do I need to go to the right or to the left? And the answer is no. So my x coordinate is 0. And then what is my y coordinate? Well, I went 3 blocks up, so that's positive. So 0, 3. So 3, 0 turns into, or J, 3, 0 turns into J prime 0, 3. And I will let you do the other point here, J and also K. Make sure you label those. And then also problem number 2, I've plotted E at -4, 1, and I will let you rotate that also. Tell you what, let me go back here because I did want to do K for you, show you what that would look like. Point K, remember you break it down into your horizontal component and also your vertical component, and notice my horizontal is 1, 2, 3, 4 units, and then my vertical is 1, 2, 3. Now I rotate that 90 degrees around the origin, and I still have, this is still 4, the blue is still 4, and my green is still 3. And notice, just like I went down the blue road and then turned left on the green road, went 4 blocks down and then turned left and went 3 blocks, so also do the same thing here after the rotation. Go 4 blocks down and then turn left and go 3 blocks. And then once you, so where there's that point right there, okay. But again, I do not need my tracing paper. Just think of it as, okay, I got my 4 and 3, so bring it on the 4, go 4 up, and then turn left on 3. It'll give you the same point. It is easier to do it with tracing paper, but you still should be able to do it, kind of visualizing it in your mind there. And so this point here is going to be K prime, and I'll let you figure out what the coordinates are. But be careful. Again, go to the origin and don't just trace the same road that you traveled. You want to do the x-coordinate first. So you're going to the left here, and how many blocks are you going to the left? I'll let you figure that out. And then you're going up, so it's going to be negative is your x-coordinate, and then positive for your y-coordinate. And so put your points there, and go ahead and do that also for point L, and then draw your triangle up there. And then do the same thing for problem number 2. Hope that's helpful to you. We'll see you soon.